Hello everybody, my name's Chad Chmura. I'm a sales engineer at Mastercam, and I'm here today to talk to you about Mastercam 2023 and the updates within the Multiaxis product. So the first thing I'm going to go over is just the kind of the bare essentials of the update that happened in Mastercam Multiaxis here. So I'm going to jump into actually Mastercam 2022 here to show you something that kind of the old way of how things worked in Mastercam. So this file was programmed in 2022. You can see we've got some parallel toolpaths, some swarf, morph, and then some unified multi-axis, which hopefully some of you have experience using the unified multi-axis toolpath. The big change that happened in 2023 is the fact that some of those toolpaths are no longer available to us. So this is Mastercam 2023. You can see this toolpath gallery here. You know, it's only basically 3 rows by 4, whereas in 2022, it's a lot going on in here. There's a whole lot of different kind of redundant toolpath options, are made redundant by the unified toolpath. So the parallel, morph, project curves, and along curve toolpaths have now been removed from the software and replaced with unified. So what that means is when you have a file, if I go back to 2022, that was created with morph toolpaths, what happens is if you open this old file in Mastercam 2023, it's automatically changed to a unified toolpath without any need to regenerate. There's no user input. It just changes over to unified. So it's a pretty quick and easy process. Another really cool enhancement that happened in Mastercam 2023 that really supports this change is you can see here in 2022 there's really no information about what the cut pattern strategy is for these unified toolpaths. This is just saying it's a unified toolpath and who knows what else is going on inside there. Where in 2023 you can see we have a unified and we see it's the automatic pattern here. Or this toolpath, for example, uses the guide pattern. You can see morph, no changes to swarf here. But parallel toolpaths. So that's really the main enhancement or main change that I want to go over in 2023. And the first thing I really want to do is kind of talk about what the basically how to replicate things that you may be used to if you're used to the morph toolpath or parallel toolpath. But then I really want to talk about the advantages of this enhancement, because I know this may be something that is a big change for some people, but this is going to be something that really makes your life easier in the end. So the first thing I want to talk about is how to replace the morph toolpath or replicate the morph toolpath using unified multi-axis. So we're going to open up this file here in Mastercam and create a unified toolpath. Now, if this is the first time you've seen the unified interface, there's really only one thing to note that's different. And that's this area of the cut pattern page. The rest of the interface is the same as it's always been. You know, we're going to keep all the same functions, so nothing really new to learn, except for the fact that we can really change this cut pattern on the fly as we create this toolpath. The advantage of this is if I change my mind from a parallel toolpath to a morph toolpath, I don't have to restart from zero with a new toolpath. I can simply change my cut pattern and regenerate while maintaining all of my downstream toolpath options. So for this toolpath, let's select all these pink faces. So I'll use the color masking selection. Select all that. And to create a morph toolpath, we have always had to select 2 separate curves, a to curve and a from curve. So let's select 2 curve inputs and change these to morph. So for the first one, it will be our from curve. So I'll shift click this. Our second one, shift click there. So we have the input for a morph toolpath. Same as everything you've seen before, right? I can change to exact mode. We'll talk more about this in a few minutes. All the options here are identical. The only other change I want to make is to say from point here. And when we generate this toolpath, I can actually click the apply button here with generate toolpath checked on. This is going to generate a toolpath preview. So I don't need to fully close my toolpath interface. I can see there is our Morph Toolpath. Right, looks exactly like you'd expect. Click OK. That was a preview though, so now we're going to kind of generate this toolpath again because I had the Generate Toolpath checkbox active. If we backplot this, we can see there is a nice Morph Toolpath. So replicating Morph is extremely easy, but I do want to show you some new things that we can do in 2023 using Unified. So let's build a new one. Same drive surfaces. I guess I could have copied that, but same drive surfaces. Same tool axis control curve, front point. But now, if I say one input, you'll notice if I click the drop down, Morph is not an option here. That's because we need these two discrete curve inputs to run a Morph Toolpath. So instead, let's do guide. With guide inputs, if I shift click there and shift click there in one session, I get, if I click preview, basically the same toolpath. This is going to be Morph style, so you'll see some areas will have a tighter step over, some areas will be looser, but that's just because we're morphing from one edge to the other. The difference here with guide, and we'll go over this in a few minutes too, is all these downstream options. There's a lot more power in this guide curve style toolpath. So Unified can very much replicate Morph. It's very easy to get the same exact output, but you'll see in a few minutes why I recommend using guide every time. One thing that's even cooler about this is, you know what, we're going to say okay, and let's make a copy. So we've got a unified Morph, a unified guide that are basically going to be the same thing. Let's copy our guide toolpath. All right, so we see basically the same sort of thing. Instead of the guide or even Morph, right, I had to manually select the edges of this curve. If I get rid of this and I select this option called Automatic, Automatic has all sorts of options for creating motion, but let's say I want to use the machining boundaries to create a Morph toolpath. This specifically works on this part because the boundaries of my selection are the curves I'm using for my Morph toolpaths. So really this toolpath is basically the same as the guide toolpath. It starts at a different point, but that's no biggie. And then Morph, you can see the step over is a little different just because it's kind of a different toolpath underneath, but it still has the same interface. So the advantage of using Automatic here is if this model were to change, if I modify feature and I remove, actually let's just go remove fillets, and I say shift click there to remove those fillets. Let's make sure they all were selected, looks like it. We're going to have a couple angry toolpaths. Right, we just deleted the input curves for the first two toolpaths. So I think if I try to regenerate everything, we probably aren't going to get anything good on the first two. Right, it's going to yell at us for not having the curves. But Automatic still sees the boundary of this surface and generates a toolpath. So instead of having to manually reselect this new edge curve, Automatic is able to find it. So let's move on. That's a Morph. Let's now create a parallel toolpath in Mastercam 2023. So we're going to open up 23 again, and let's grab a parallel. And of course, there's all sorts of different parallel toolpaths, right? So if I say unified, again, we're going to machine these pink surfaces with a 6mm ball. So select our pink drive surfaces. Oops, looks like I selected only. Select all pink surfaces. And same thing as before, we have a point tool axis control. And from here, we can change our mind any number of times. So let's select a cut pattern style. Let's go parallel to a plane first, right? So let's say I want to select a plane, or instead of a plane, let's go solid face. Let's stay parallel to this yellow solid face here. If I generate my toolpath, you see pretty straightforward stepovers that propagate parallel to that single solid face. Or I could go and say, let's reselect let's go parallel to a surface. So let's get rid of this guy and say surface, parallel. Let's go parallel to these. Preview. Whole new toolpath, except we still maintained our tool axis control, right? We never had to change anything, but our cut pattern is completely different. We could also go parallel to a curve, right? So here's parallel, and in this case, let's go parallel to the purple entities of the Witch Doctor logo here. So if I say wireframe, what's actually cool, if you've not done this before, I can say let's do a color mask and select only purple entities. Say OK. If I window select, it only finds the purple entities, and now it'll create a toolpath that is parallel to those curves. Of course, that seemed to only find some of them. Let's try guide instead. I think guide we're going to have a little bit better of a parallel style motion. Now, of course, what we're seeing here too is, you know, we've got to really clean up our retracts and all that kind of stuff. But one thing I like to do here is instead I can just show, just for the sake of demonstration, since we're really only interested in the cut pattern here, using the advanced toolpath display, turn off retracts, turn off transitions, and now you can really see the base toolpath that we get. It's a fully propagating motion based on the shape of this logo. So you can create a lot of really cool motion with Unified and not need to restart your toolpath from scratch. So that was parallel to, and of course, you know, we could also go parallel one more. Pretty simple to just one single solid edge curve. Nothing crazy there. So now back to straight parallel motion based off of an edge curve. So Unified is pretty impressive in that regard. So moving along. Now let's replace a along curve toolpath. So this used to be called cuts along curve, or let's see, don't save. This file is of course also a mesh file, so there's a little bit of work to do up front. Oh, but so what I wanted to mention about along curve, that the naming of that toolpath is a little bit unclear. So we're going to see in a second how 2023 deals with that. So let's go and create a power surface using these edge curves. These edge curves were actually created, oops, it looks like I'm getting, let's turn off my color mask. The edge curves were created just by creating a manual spline using points on the mesh. So there's a pretty decent little surface that we're going to use to create our toolpath. And if you're familiar with the cuts along curve toolpath, you need your along curve. A tool I really like to use to make that curve is curve center. So we're going to make a curve that is centered between the green curve and the purple curve. Right, there's our along curve. So if I go into Unified, grab our ball end mill, grab our machining geometry, and now we're going to use a perpendicular. So cuts along curve is essentially just perpendicular to the input curve. So we're going to do a perpendicular toolpath on this edge. Just keeping tool motion normal to the surface. There is a very simple, quick and easy perpendicular cuts along curve toolpath. You'll see though, this perpendicular curve kind of, you know, it creates a couple bunches of motion here. So what I can actually do is go into refit spline. We're going to clean this spline up a little bit. Let's delete the original. I'm not sure how big to go here, but let's say 100 thousandths. And this is going to smooth that spline out. I say OK. Deleted my original spline so I can just regenerate. And now that motion is much more uniform from start to end. And the final step to get this to actually apply to my mesh file is to simply turn on a collision control that retracts the tool along its axis for any collisions with the mesh. So now this tool will retract along its normal, and then we get this pretty decent cuts along curve toolpath to machine that area of the horn. And again, because this is unified, if I completely change my mind and say, well, I don't want perpendicular motion, I want parallel motion. Well, before 2023 or before unified, we'd have to start over again. We'd have to do all those steps over again and say, okay, we're gonna change to a guide or a parallel. Here, all I do is say, well, let's go guide, regenerate, and this entirely different toolpath comes out. That runs parallel to the horn. So, pretty cool. Next on the list is a project curve. So this is a pretty quick and easy one. Essentially, this is just, for engraving logos and things like that. But it is, again, inside the unified toolpath. So the next thing we'll do here is create a project curves toolpath. So let's go unified, same ball end mill, and the same drive surfaces. So we'll grab our pink surfaces. And then some curve inputs. You'll notice we can select project. And when I window the logo, you'll see down here the familiar settings for the project curves toolpath. This is a metric file, and this logo is way off the surface. So let's enter something like 50 millimeters of max project distance. And then you'll see that we get the Witch Doctor logo projected onto the part, again with bad retracts. We'll figure all that out later. But there is our project curves style toolpath, again, all within the unified interface. So the next thing I want to talk about is actually something that's brand new to Mastercam ever since the introduction of the unified toolpath. This is something that you would not be able to do without using unified. So let's open up a new file. And so what we're going to talk about here is creating flowline motion. And of course, there already is a multi-axis flowline toolpath, but unified gives us a little more power. First thing we have to do, though, is kind of prep this model for creating a toolpath. I'm going to split the solid faces. This is one solid face, the whole blade. So if I split this using, I think it's the V flow lines, and let's only focus on the face of the blade here. So let's say toolpaths, unified, select this lollipop, select our machining geometry. We'll not play with tool axis control or collision control quite yet. Now, in here, you'll see flowline. So let's do a flowline U and preview. Let's see if U, so there's our perpendicular to the flowline motion, or flowline V, and let's generate this toolpath now. So with this generated, this is something that you could do before using multi-axis flow. However, multi-axis flow is kind of getting a little bit old, right? It's not really a whole lot of new development in here. This is one of the original multi-axis toolpaths in Mastercam. Unified surface flow has the full power of the unified toolpath with tool axis control, collision control, linking. You can do a lot more using surface flow within unified than you could do with a traditional multi-axis flow. So this is something that unified is really changing the way that people would use multi-axis motion or create multi-axis motion by allowing us to create flowline motion with such an advanced interface. So that's basically how to replicate toolpaths that you could already create in Mastercam. So now let's kind of take a step forward into the things that Unified allows you to do that you could never do before. So let's open up this next file. And what we're going to talk about here is the way that toolpaths generate their stepovers. So we've got this file here, and I believe I've got a simplified version of it, where we want to machine these pink faces on the inside. I'm going to propagate from this orange curve all the way to this end over here. What we've done here is create a unified parallel toolpath. So this is a traditional old parallel toolpath. When we backplot this, of course ignoring tool axis control, what is going on with the stepover, right? It's seemingly consistent in some places, inconsistent in others. Well, this is all to how the stepovers are generated in Mastercam. So if we look on the advanced options page, if you're familiar with approximate versus exact mode, this should hopefully be a review. The way that approximate mode generates toolpaths is purely based on offsets. So we're basically creating this offset. These cylinders are offset by our stepover. Every time this offset intersects with our drive surface, we get a machining pass. So as we get out here, we intersect over here and over here before this next one. So we get a pass there and a pass there before our next pass on this this normal face. So simply by changing this over to exact mode will work differently, where it propagates by measuring along the length of a surface. Exact mode will not generate stepovers through open air. So if I change this over to exact mode, we see that same toolpath becomes much more useful. Now, the reason why I just wanted to kind of cover this is, first of all, to make you aware of approximate versus exact if you weren't already. But some of the stuff we're going to talk about now is purely based on exact mode. So when we're not using parallel or morph, if we're using automatic or guide curve motion, right? So guide curve and automatic, which are essentially the same thing, just one is automatic, one is manual, is taking full advantage of exact mode. See, it's not even an option here to change approximate to exact. This is purely exact mode. So the fact that those input styles rely purely on exact mode gives it a lot more power that we'll go over here in a second. The first option that is a really powerful tool in Mastercam 2023 is being able to control how the toolpath is generated. The name of this slide here is contact point, but we're actually choosing in between generating a toolpath at the tool center versus the tool's contact point. And I'll show you what that means here in a second. So when we're looking at this part, let's say we're doing some fillet finishing toolpaths here on the outside of the blade. Right, there's our, actually let's turn off our advanced shading so we can see things a little better. View, or turn everything back on again. So this toolpath is a unified guide toolpath where we have selected this orange curve as our guide curve, right? Let's just make sure of that. Right, there it is. And these pink surfaces are the drive geometry. The first thing you'll notice is this guide curve does not need to be at the very edge of the geometry. It can be somewhere in the middle and still be something useful for us. So as we watch this toolpath run, it seems to be pretty nice through here, right? But then we get this really crazy tight step over in the corner where things are definitely not working as well as we'd like. And this is something that happens especially when you have a toolpath where the tool is not running perpendicular to the surface. So it's worth noting that these blue lines, right, represent the very tip of the tool. if we were to shade this toolpath using tool center point, the step over would at least look a little more consistent. It would still bunch together in this corner though. What's happening is the step over of this toolpath is being measured on the surface. So this surface, if you drew basically whatever our step over is, something like a millimeter or something, right? 1 millimeter step over. If we drew a line every 1 millimeter, that tool would reliably contact every single line, basically plus or minus nothing. So even though, you know, this tool is really, actually it's even bigger than this radius, right? So if this tool were smaller than this radius, you'd see perfect 1 millimeter separated marks in the actual material. The toolpath itself appears to bunch, but the contact point is changing 1 millimeter per pass. So I think we can agree in this case that with the cutter being larger than the actual fillet radius, there's no point in having so many passes in here. So what we can do here is change this over to wherever this option lives. Here it is, calculation type. Instead of contact mode, we can calculate step overs based on the tool center. So what happens here is Mastercam actually offsets the drive surfaces by the radius of the tool and generates the step overs at that point. So now what we get is a step over that's much more reliable. You can see very consistent step overs, much cleaner motion. Now, you'll also see here, because we're using a guide curve, this curve is not perfectly parallel to the edges of our drive surface. So we get these short little machining passes here that really, I would argue, would cause more problems than good. So Unified has an answer for that as well. I can say on the containment field, trim cuts that are shorter than, I'm just going to guess, 20 millimeters. I'm not sure what number to put here. There we go. So now we trimmed any cut that is shorter than 20 millimeters in length, and we have nothing but our full passes. So I would say this is a much nicer toolpath to run and will result in a much nicer finish, thanks to the fact that we're using guide curve input. You know, you could use something similar with a Morph Toolpath, but you'd end up having all sorts of ugliness inside of this corner. Guide curve allows us to do a whole lot more. So another thing that is, this is actually new in Mastercam 2023. If you were using Unified in 2022, this is something that you'd not be able to do. Basically, if and when I go back to 2022, not having this option it's actually pretty painful. It's something that I've really gotten used to, and I think it's really, really powerful. So we've got a toolpath here, but it's kind of boring, kind of simple. So I believe our drive surfaces are already selected. Let's say instead of being parallel to a plane, we use a guide curve. And let's just select the outside of this logo as our guide curve. Let's just even apply this. Let's see how real this toolpath is. Of course, the retracts are pretty crazy, but there's our motion. And remember, I mentioned in that last demo that the guide curve does not need to live on the extreme edges of either of these faces, right? This is in the middle of the face. So let's say that I would prefer, in this case, to only machine on one side or the other of this guide curve. Now, again, this is something that you could not do in 2022. There's this option here called Propagation Direction, where I can say only propagate to the left. And now we get this really cool effect that only runs from the outside of the surface to our guide curve. So essentially, you know, picture what it would take to get this style motion without using this option. You know, we're basically trimming out maybe a collision control area or something like that. But that would be even really hard because the passes are essentially being generated by our collision control area. So this is a really cool cool way to create some motion. Let's do another toolpath in this part actually, and I want to show one other interesting fact here. So let's say instead of guide, let's just go and talk about the differences between these options here. So let's go machining boundary parallel. And in this case, you know, we have a toolpath that only machines from here out. Let's now machine from here in. So what we do in this case is just set a containment, user defined. Right, so here's our nice little containment boundary. And let's say apply. Oh, do I have a... Well, let's go both for now and see what I just did. All right, so we now have a toolpath, and let's kind of tighten up our Stepover so we can see a little better. That is parallel to this same logo, right? We just used automatic, but it really isn't automatic, right? Because we had to manually select our containment. But this is a good chance to talk about the difference between machining boundary and the other options. So machining boundary takes into account any containments or avoidance regions or anything like that, and create Stepovers based on that. So essentially, you'll see this toolpath is almost the same as the one before, right? We could do this in that first toolpath because it's using this to create the motion. It's just propagating inward instead of outward. So let's say instead that we use a surface boundary. So surface boundary ignores the fact that there's a containment. It now will select, in this case, let's even just select one drive surface. Let's just grab this one. Its offsets are based on the outside of this surface. So when I preview this, you'll see that, you know, it's mostly vertical motion, right? Because this is a long, skinny surface, but the tool motion is based on the edges of this surface. We can also create something a little interesting where center parallel. What this does is Mastercam finds the exact center of that surface and simply just propagates outward with circular motion. And this is actually a really cool thing to do on a trunnion machine, because this is a great way to create just that C-axis spinning motion and have perfectly concentric circles. And of course, you know, I've got to clean up my lead-ins and all that stuff, but if we just turn on advanced display just to see the actual cut motion, right, there's our really simple cut motion there. You know, you can create some really interesting effects with your toolpaths. You have a lot of control over how this cut pattern is created. But again, being inside Unified, you never have to reselect your tool axis control or collision control. It all just remains in the background. So another little quick one here is a skip hole. So this is a pretty cool, powerful piece of technology within Unified. And in this case, we've got a familiar part here. Let's say we want to machine these pink surfaces. So let's go Unified, grab a ball mill, grab some machining geometries, and we'll create two guide curves. There's one, there's two. And I preview this. Now remember I said before, guide curve does not create toolpath propagation through open air. So what's happening is, as we reach the end of this hole feature, you know, this straight line here is 1 millimeter, but this straight line here is also 1 millimeter, and it starts to form this radius effect where the cutter falls into the hole, and then it kind of fades away, and then it falls into this hole, and this motion is obviously not something we'd want. In this case, a Morph Toolpath would have created something a little nicer. However, with Morph, we lose a lot of these extra options that we like. So what I can do here is say fill holes with no cuts and holes. So now Mastercam basically created fill surfaces inside of these holes, and the toolpath stepovers are cleaned up. Even better, I could say, well, I don't want to retract and come over, because if I had advanced display turned off or turned my retracts back on, you'd see a big retract. It would lift over and come down. With no cuts and holes turned off, the cutter just runs straight over that whole feature and into the next cut. And I didn't need to manually create any fill surfaces or anything. This just uses the natural flow of that surface. So again, something only possible in the unified toolpath. And now the last thing I'm going to show you here is, for me, the most important enhancement in Multiaxis for 2023 is the ability to select a reference surface. I'll show you what that means. So this part I programmed a couple years ago, and this is an actual toolpath from that part where I really wanted to semi-finish a large area of this toolpath, of this part, in a single toolpath. So the first operation here is just set normal to surface, right? So the tool, the tool tilt motion is pretty crazy. You'll notice this is an old Morph Toolpath that was adapted up to unified by opening it in 2023. So this is essentially just a morph between two curves. But again, you know, normal to surface is not going to work here. And I would admit this is a pretty ambitious toolpath that, you know, tool axis control is not going to be very simple here. You know, I can't select one chain I want to drive to, or one point, or I'm really kind of forced into using collision control to avoid these collisions, right? Well, or you could go the really old-fashioned way and create some manual tilt lines. So each one of these lines was created and manipulated independently, so I could select them for this toolpath that uses tilt line tool axis control. And so you'll see that, and this is the actual toolpath that I ran on this part. You know, it worked pretty well. It's a little chunky, a little jumpy, but it got the job done. There were no collisions. You know, there's really finite control at every single point of the toolpath, but you know, the motion wasn't the best. It's a little bouncy, but hey, it worked. The biggest problem here is there's something like 30 lines here, I think. Yeah, 30 lines that I had to manually create. Well, in 2023, there's a new tool called Reference Surface. So the first thing you need to do is build that surface. So I've already gone ahead and pre-modeled these lines. You'll see these lines are really just nothing special, right? They're just tossed in there randomly. I basically drew a line from the top of the curve to the bottom of the curve. Pretty simple. So if we create a loft, and we loft all these curves, so you'll notice this interface is new in 2023, where if I select one backwards on purpose, for example, and let's go in and select the rest of these. All right, now you'll see the surface flip on itself here. I can actually find which curve is the problem. Right click, reverse it. I can also click and see right now we're looking at, you can't really tell the color, but this is the back side of the surface. Now it's the back side. I can flip the normal before I even generate this thing. All right, so there's our reference surface. You'll see it's really nothing special, right? It doesn't cover this whole surface. It's just a really ugly but smoothly flowing surface. So if I take my original toolpath and I say tool axis control based on a reference surface, I can select this. Now this is a new option in 2023. It's also worth noting this option exists in the convert 3 to 5 toolpath, which is huge for that toolpath as well. And let's generate this. And now with that reference surface turned off, oops, let's move this to 12 as well. When this generates, we'll get It's a bit of a hefty calculation. There it is. This motion, of course, it's really big. Here we go. Is using that surface. Wait a minute. No, it's not. Oh, it is. Yeah, okay. Let's get down here. We can tell. All right, there we go. So now this motion is even better than the guide curve or the manual tilt lines motion. Right, this is completely flowing motion, far easier to create, and it's also worth noting in this case that when you turn on this option down here called smoothing, this pulls out something like 95% of the tool axis change or tool tilt reversals that are created with this method. So I really recommend using smoothing here. Now, this part is just kind of a quick and dirty way to show this feature. I really like to show this working on a mesh file. So if you've ever programmed a mesh file, you would know that it's really difficult to get, clean motion and clean tool tilting. So it's worth noting this unified guide curve toolpath is driven right to this mesh. It's actually, I created a guide curve down here. So it's propagating using propagation direction selection, and just creating this pretty nice toolpath. The actual cut pattern is nice. However, the tilt motion is not, right? We've got all these crazy different tool axis directions. So in the past, the way we would handle that is we would create these clean core surfaces. And this is a very manual process that, it becomes a bit difficult to create these curves or these bodies. I can assure you this took a long time to model all that. Whereas instead, what I can do is using a copy of the actual drive surface and our mesh tools, I can say, well, let's smooth this mesh. So let's grab this whole mesh here. And we're going to smooth out a lot of the detail. Let's say we minimize the area, 5 iterations. Let's see what we get. It should turn into kind of a blob. But we remove a lot of the detail, right? So using this as tool axis control should give us something much nicer. So let's go in here and say tool axis control based on reference surface, that being this one, and generate this. Now back on the original level, we have the same stepovers, right? The same really well-controlled stepovers. But now if we look, so, we're not getting these fully crazy. Well, I guess it's still pretty tilty, but this is now using that clean core mesh. It really does not look like it though. You know what? The way we can even handle this is to smooth this out even more. All right, so let's go smooth area on this guy. Let's go 5 more. Let's turn this into a real total blob. There we go. So now we should be a lot less motion over his nose. All right, we regen this. Even though it took 2 iterations to model that, right, it was still a lot faster than creating those manual. All right, I didn't like the fact that I changed those surfaces. So now back on the original Abe Lincoln body here. Backplot this, and now let's see. Do we get this full tilt? There we go. See, now we're not perpendicular to that nose anymore. So now this really just relies on proximity to that tilt surface. So you see this is far smoother motion, obviously, than using direct to this this mesh file. And again, in this case, since we're driving to a mesh, as far as tilt motion goes, turning on smoothing actually will visibly change the even the back plot will look a lot better, because we're staying normal to each of these facets on the smoothed body anyway, and that creates a really faceted tilt strategy which also creates lots of reversals. So if we just run this with smoothing turned on, you'll see this is far nicer motion. That was extremely easy to create. So this this tilt relative to reference surface option is really cool in Mastercam 2023, and in general, the whole unified toolpath is a really big improvement that I hope you try to use. You're going to have to if you want to use Mastercam 2023 surfacing. It's your only option. So that said, if you do have any questions on the unified toolpath or any feedback, feel free to send it my way, and I can pass it on, or I can help you out getting that tool motion figured out. It's really my favorite thing in Mastercam right now is to program multi-axis using unified. It's really powerful. So hopefully you learned something with this presentation, and thank you very much.